Hi, this is Monique Rice from Advanced Kentucky. This particular session is for AP Computer Science Computer A. AP Computer Science A, I'm sorry, content review
Oh, that's
session.
okay.
The topic is array lists and 2D arrays, and we're happy to welcome Rob Schultz from Bellbrook, Ohio, as our presenter today. I'll stop sharing my screen, and Rob, it's all yours.
Okay, so let me pop my screen up. Um, let's see, where do I want to be? There we go. Okay, so as Monique said, my name is Rob Schultz. I teach at Bellbrook High School in Bellbrook, Ohio. This is my 21st year of teaching, and I guess my 20th year with AP Computer Science A. I've been teaching AP Computer Science A since back in the C++ days. I'm happy to be with everybody today. The focus today for the first half of the session is going to be array lists, and then for the second half of the session, we're going to get into 2D arrays. So for those that are with us, I guess what I would like to do to make sure that I'm using our time wisely and answering questions for those that are here, if there are any specific things that are specific questions you have about array lists or specifics that you want to cover about array lists, please feel free. I like to keep things very informal. Please feel free to unmute if Monique, if that's allowed. Are they permitted to unmute and ask questions?
They are permitted to do whatever you'd like them to do, Rob.
Beautiful. Okay, that gives us some flexibility. So for those that are with us, live at this point, feel free to unmute. And if you have any questions along the way, let me know. In fact, this might be a good time before I start to make sure I'm heading us down the right path. Are there any specific questions about array lists that you'd like to have answered today while we're together for the next 50 minutes or so before we take our break? Okay, you guys are like my actual class of students. It's like crickets. Okay, no, so I'm assuming we're good to go, and we're just going to kind of talk generally about array lists. At some point, we'll pop up JGrasp and we'll do a little bit of experimenting with array lists and kind of play around a little bit. So, so first, let's talk a little bit about what array lists actually are. So, Java includes this collection class called Arraylists. I'm going to move my little window here out of the way. Java includes this collection class. It's like an array, but it's called an array list. So I tell my students that an array list is kind of like an array on steroids. You know, with an array, and that's what we talked about the last time we were together on the 20th back in March. With an array, when I declare an array, I have to specify an exact size. I have to define a physical size so that I know exactly how many elements I can handle at any given time. With an array list, we don't do that. With an array list, when we declare it, we don't have to specify an initial length. It does have a default length, but that's the compiler's issue. We don't have any need to worry about what that is. All we have to worry about is the fact that as I add things to an array list, it dynamically changes the size and keeps track for us. And if I remove things from an array list, which is really difficult to do with an array, I can literally take something out of an array list and it'll decrease the size. Whereas with an array, it's possible to go in and set a value to null or set a value to 0, but it doesn't physically change the size. We would have to create a brand new array, copy everything from the old array to the new array with one less size, skipping whatever object we wanted to try and remove. So with array lists, it's much easier to add things and remove things and do what we want to do. So so when we insert an object into the array list automatically updates its size and adds cells to accommodate any new objects. Now, I specified the word objects because this is one of the pitfalls of an array list. With an array, we can create an array of primitive data types. It's perfectly fine to create an array of ints or doubles or booleans or whatever we want, but array lists can only contain objects. Okay, so I have here in front of me, and I really need to update my clip art. This is like 1980s clip art, I think. But I have this array list that contains a variety of different objects. I have a string object in the first element. I have a CD. I think that was a CD. It was probably a laser disc back in the day. But it's a DVD, whatever you want to think of it as. I've got a dog object in the second index, index position 2. I'm pointing with my fingers if you can see that. In index position 2, I've got a student object in index position 3, a book in index position 4, and a shape in index position 5. So I can put whatever objects in there I want, but the compiler will only recognize objects. And well, before we get into any more with the difference between primitives and objects, let's talk about some of the benefits of having array list as a class. With an array, it's basically the same as a primitive data type. It's basically a collection of buckets. I always tell my students a variable is like a bucket that I can put something in and take something out. So you can almost think of an array as a collection of buckets. I can put things in, take things out. That's about it. With an array list, we have some other flexibility. There are other things we can do. Because an array list is an actual class, there are array list methods that I can call on my array list to do certain things. And this is just kind of a sampling of what's there. So, I can check my array list to see if it's empty, and it's going to return true if it contains no elements, or false otherwise. I can check the size. And this is one of the things, I might have mentioned this the last time we were together. I keep this list of questions in the back of my head. If I ever have my moment to meet James Gosling and sit down and ask him questions about the development of Java, this is one of those questions. Why did they decide to use size for array lists, but they use length for strings and arrays? Why did they not do length to keep things consistent? But so I can check the size of my array list. I can get an element from a specific index position. And this is something that's a little different. With arrays, we use our square brackets to get something. With an array list, I have to call the get method to get whatever's at a specific index position, and it will return that element. I can set something. So I can set a specific, I can set an object at a specific index position to be, a different object. And this will automatically return whatever the old element was that was there, whatever the older object was. I can add things at a specific index position. There is also an overloaded add method where I can just say add an object, and it'll just add it right to the end. It'll kind of append it. I can remove things. I can find the index of a specific object. And if I want, I can clear everything in one shot. So it's not like with an array where I have to create a for loop that goes through and wipes everything. All I have to do is say, my list.clear, and it'll clear all of the elements from the list and reset the size back to 0. So these are some of the things that we can do with array lists. I should probably point out, as far as the AP Java subset, as far as things that are on the AP subset that'll be covered on the exam, all of these are covered on the exam with the exception of clear, is empty, and I believe index of. On the exam, you need to know how to get things, set things, add things, remove things, and you need to know how to get the size, obviously, so that we can use those when we traverse an array list. But the rest of these I just threw in because they're useful. They're not something that you would necessarily be tested on, but they're useful to know as we start working with array lists, if I need to clear something or if I want to find out if something's empty. So, okay. Now, again, please, I'm going to keep talking. I tell my students, I'm going to assume that as long as I don't get questions back, that we're good to go, and I'm going to keep chugging along. So if at any point you have questions as we're going, or if something comes up that you want to ask a question about, please feel free to unmute and let me know as we go. Okay, and that goes for both the teachers and the students that are with us. Okay, so we talked a little bit about the fact that array lists can only contain objects. So I can create what's considered to be a generic array list. And when I say generic array list, it means I can put in whatever types of objects I want. And the compiler's going to accept whatever type of object I give it. So in this case, like I said, we've got a string, a DVD, a dog, a person. The problem with that is if I go to take something out of the array list, the compiler is going to treat it as if it knows or for what it thinks that it is. So if I create a generic array list of just objects, the compiler doesn't realize that the element in position 0 is a string, and that the element in position 1 is a DVD, and that the element in position 2 is a dog. All the compiler knows is that they are objects. And we could take some time here and talk about the hierarchy of objects and things like that. But if the compiler's treating them as generic objects, that means the compiler is only going to let them do what generic objects can do. A default constructor, toString, things like that. If I have something specific in here for strings, like substring or to uppercase, the compiler isn't going to realize that it's a string. The compiler is going to think of it as an object. So if I try and take whatever's in position 0 just as is, and find a substring, the compiler is going to say, hey, you can't do that. This is just an object. You haven't specified that it's a string. So the compiler doesn't realize that. The compiler isn't going to let me take the element from position 2 and tell it to bark, or the element from position 3 and tell it to take a test. Because the compiler doesn't know what they are. So if I create a generic array list with just generic objects, I have to be prepared to cast what's there so that I can specify, I can specify to the compiler what's really there. If I want to pull what's in position 3 and treat it like a person and tell it to do person things, then I have to cast it as I remove it and save it as a person. So now the compiler is going to say, oh, okay, my person is a person, so we can tell that person to take a test or walk or talk or do whatever. If I have the element in position 1, I can cast it as a DVD if I know that's what it is and take it out and store it as a DVD. And then I can tell it to do DVD things, play the DVD, tell me the title of the DVD, tell me the, director of the DVD, whatever. Okay. So
Is there like a method or a test to test what kind of object is in my array list?
There is. I don't recall what it is off the top of my head because this is kind of the old way of doing things. Okay, so this is not part of the subset that you have to worry about casting things. But again, I just kind of wanted to describe what's really going on behind the scenes with our array list. So there's a way, I think it's called instance of, if I can take an object from an array list and say, my object dot instance of person. And if that's true, then I can cast it as a person as I remove it. So, but there's a much easier way, and that's kind of what I'm leading into. I don't remember what version of Java it was. A version of Java was released that now we can be explicit when we define array lists. Okay, so if I create an array list and I know that this array list is going to contain only dogs, I can explicitly state when I create it using these brackets, I can say, okay, I'm creating an array list of dog objects. And again, I need to clean up my clip art. That is really old pixelated clip art. But I can create an array list of dogs called my dogs. And then from that point on, the compiler knows that, okay, anything that's in this array list is a dog and it can do dog things. So I don't have to worry about casting anymore. And as far as the AP subset's concerned, this is really what we're going to get into. There won't be a point in the AP exam where you have different types of objects that you have to worry about figuring out what it is before you can do things with it. Anything that'll pop up on the AP exam, you're going to be told specifically that it's an array list of dog objects or an array list of square objects or an array list of student objects or bank account objects or whatever. Okay, so this makes life much easier for us. Now that we can explicitly define the things that go into array lists, we know that we don't have to worry about casting. Anything I take out of this array list called my dogs is going to be a dog, and therefore all of those objects can do dog things. Makes sense so far? Yeah.
Will I have to worry about deciding whether to use a regular array or an array list?
On the AP exam, no. I don't think there will be. I want to be careful how I answer that. On the free response questions, unless it very specifically says to use an array list or use an array, you have full leeway to do whatever you want. So as a reader that's been at doing this for a while, I've seen students where you had to, maybe the question said you had to copy certain elements from an array and put them into an array list. And so on that question, maybe you create an array to hold elements specifically to do something and count them, and then you put them into the array list. I've seen other students take the same question and create an array list that hold those same elements and do certain things. So, I mean, you really kind of have the flexibility to do whatever you want, provided the question doesn't give you very specific details that you have to create an array list or you have to create an array. It's kind of a vague answer to your question. So it's kind of a yes or no thing. There will be some questions where the question will specifically say, you have to create an array list that contains this. There could be questions where it says, create an array that contains this. But if in the process of doing what the question's asking you to do, you feel like it's helpful to create a little helper array list to contain values or create an array to contain values, you have the flexibility to do that.
Okay.
Does that make sense?
Yeah.
Okay. All right. Okay, so let's see. At this point, we've talked about kind of the origin of array list, that it started out as a generic thing, and then we were given the ability to explicitly define things. Let's talk about primitives, because I said that array lists can only contain objects. And generally in my own class, when I start to get into that, my students go, well, wait a minute, you're telling me I can't put an int? I can't create an array list of ints? Well, we can. okay? But we just have to we have to make the compiler happy. You know, I jokingly told my students earlier this week that I feel like 90% of programming is like being married to the compiler. You know, if you make the compiler happy, things are going to be good, right? So we have to make the compiler happy. So here's what we can do. Every primitive data type has what's called a wrapper class, and it's like a box. Okay, so int, the primitive data type int, has a wrapper class called integer. So integer is a class. There's an actual integer class, capital I, that is like a box, and it has methods, and we can do different things. I think the integer class has things like to hex string and to octal string. So I can give it an integer value, a primitive data type integer value, and then there are methods in there that'll convert things and do cool things. None of that part is on the AP subset, but this wrapping and unwrapping is, I mean, that's literally what it's called. That's something that is taken care of in the background. And up until, I want to say 2019, the 2019 exam, wrapping and unwrapping was actually part of the AP subset. That was something that we had to teach. So we had to teach students, I don't know if I have a slide of it without it being automatic, but we actually had to, if I wanted to take an int, a primitive data type int, and put it into an array list, we had to add extra code that would take that int, put it into the box in an integer, you know, an integer class, wrap it using a specific method, put the box into the array list, and then if we wanted to get something back out, then we had to get the object, we had to get the value inside. So it was literally the same idea as, you know, taking a primitive data type, putting it into a class, or into an object, put the object into the array list, and it was very, very tedious. And as of, I don't know, probably 5 or 6 years ago, Java handled all that automatically. So in 2019, College Board finally decided, you know, all of this is automatic. It takes place in the background. It's not really anything we need to teach anymore. So now we can put primitives into array lists, and all of that wrapping and unwrapping takes place automatically as long as we specify explicitly that instead of creating an array list of dogs, we're creating an array list of integers spelled out capital I. So if I create an array list of integer objects, then that means that I can put ints, primitive data types, into the array list, and it'll automatically package my int into an integer object, put the object in. It'll do all of that wrapping and unwrapping for me automatically. It's like, it would be like Christmas time. If you go shopping, there's somebody there that automatically wraps your presents for you, which they do, but then they also come home with you and unwrap your presents for you automatically on Christmas morning, which wouldn't be as fun. But in this case, all of that wrapping and unwrapping takes place automatically for us. So we don't have to worry about that anymore as long as we specify when we create the array list that we're creating an array list of integer objects. And then at that point, I can add whatever I want and remove whatever I want. As far as it's the primitive that matches that object. Okay, so I'm going to pause at this point for some questions. We've covered a lot of stuff in about 20 minutes. So any questions at this point? Okay, we have a quiet group. Okay, so some questions that I would ask my students at this point. Okay, what are the pros and cons of arrays? And if you would like to unmute and answer some questions, especially if you're one of the students in the group, I'd love to hear from you. What would be the pros and cons of arrays versus the pros and cons of array lists? I'll give you a couple seconds to think about it if you want to answer, and if I don't hear anything, I'll give you some answers that I get from my students and we'll move on. Okay, no takers. Okay, so when I ask this question of my students, you know, what are the pros and cons of arrays? The pros of arrays are that if I'm dealing with a small set of numbers or values, and they're going to be primitives, it's usually, at least my opinion, and the opinion of many, I think, that arrays can be easier to work with. You don't have to worry about, you know, adding extra methods and getting this or adding that or setting this. You just create your array, especially if you know that you're going to have a set size, and you know that you're dealing with primitive data types. Arrays are usually a little easier to work with. You just do the square brackets and you put things in and take things out. The cons of arrays are that if I'm dealing with a set of numbers that the size is going to change, I can't do that with arrays. So that's where array lists kind of come in handy. As far as the pros and cons of array lists, the biggest pro is that array lists dynamically size. I don't have to specify that I'm going to have 1,000 elements in my array list. if there's a possibility I might only have 10, I just create an array list and then I add things as I need to and I remove things as I need to. So so that's probably the biggest benefit. I would say the cons of array lists is just the overhead and adding some extra things if I'm dealing with primitive data types. But again, I mean, every situation is going to be a little different depending on what it is you're trying to do, and you know, whether or not you have a set number of values or a set number of elements versus an array list where you wouldn't. Obviously, the biggest difference between arrays and array lists, you know, arrays, I can create an array of objects, I can create an array of primitives, but I have to give it a set size. With array lists, I have to create an array list of objects, even if it's an object that can contain a primitive, but then I can dynamically change the size. And, you know, when would you choose an array over an array list? Well, we've already kind of talked about that. If I know specifically that I'm dealing with, you know, 100 values that I have to deal with, and they're all integers, you know, I'd probably go with an array over an array list. But if I've got objects and you know, I'm going to be adding some as I go or removing some as I go, then I would take the array list over an array. So, and then, you know, there might be other questions that we ask our students, but questions from the students, you know, the main question I get from students when we start talking about array lists and we start talking about all the things that array lists could do, it's kind of like math class when, you know, maybe you show them, you know, Monique, you teach you are a calculus person, so it's kind of like when you make them do derivatives by limit, you know, and then you show them some of the shortcuts and they go, why would I ever do it by limit if I know all these shortcuts? Well, this is kind of the same thing, you know. Why would I ever use an array if I could use an array list? Well, there are actually times where it makes more sense to use an array than an array list. Again, it just kind of depends on what we're doing as we go. So okay, so what I want to do next is a little coding time. But I want to open the door for questions. If there are any questions, are there anything, is there anything specific that you'd kind of like to see before we get into this? You know, anything that kind of sticks out in your mind that you have questions about array lists? And again, for both teachers or students, I'd love to hear from you so that I can make sure that I'm hitting questions that you have.
For array lists, can you use enhanced for loops?
Yes, you can, absolutely. So I'm glad you asked that question. I'm going to make a little note here so that we can do an example of that. Let's see, okay, so as we get in and play, we'll do an enhanced for loop. Other questions? Okay, well, let's go in and we'll play a little bit. I'm going to switch my screen over to my JGrass screen. There we go. Okay, everybody see that okay?
Yes.
Okay, so I've already got this little class kind of set up, so I didn't have to type all the extra stuff. So we're going to go in and we're going to create an array list. We'll create a couple array lists and just kind of play around with them a little bit. And there are a couple of things specifically that I want to show you how to do. The first thing we probably need to talk about is the fact that and again, this is another one of those questions that I keep on that list in the back of my mind for James Gosling if I ever have my moment to sit down with him and ask him questions. And I suspect I know the answer to this one. Array lists are not part of Java, I guess would be the easiest way to say that. You know, there are certain things that are part of Java, the math class, arrays, different things like that are automatically there. We don't have to import them. We don't have to do anything fancy. But with array lists, we have to import them. Java.util.ArrayList. And I suspect two possible reasons for that. I would love to ask him specifically, why do you have to import array lists? Why are array lists just not automatically there as part of the toolbox? And I suspect that one possible answer would be that array lists were added after Java was already established and created. So things like math class and arrays, those were probably there from Java version 1 on, and they're just part of Java. Array lists were kind of an add-on down the road. But the other thing I suspect is that, Java is kind of like packing a suitcase for a trip. If I'm going on a trip, any trip, there are certain things that I'm going to take with me no matter where I'm going or why I'm going there. My toothbrush, my toothpaste, my razor, my hairbrush, all these things. So I kind of suspect that the math class and arrays kind of fall into that category. But then there are other things that I'm only going to pack if I'm going on a trip for a certain reason. If I'm going on a vacation to the beach, I'm going to specifically pack my swimsuit, which I might not pack for other things. And I'm guessing array lists kind of fall into that category. I'm guessing that array lists probably require some overhead that you wouldn't want to pack and take with you unless you know you're going to need it. So I would love to talk to him about that and find out what the specific answer is. But in any case, we have to import array lists. And then when I create my array list, let's start with an array list just of integer objects. Let's see, we'll call this my list 1. So we have to, I guess I shouldn't say we have to, but I would recommend being very specific as you do this. There are times, I'm not even going to get into it because I don't want to confuse things. My recommendation is, as you're creating an array list, be very specific, both in the declaration and in the construction of what it is that you're actually putting into the array list. If we're creating an array list of integers, make sure that you're being specific in the declaration of your variable, that you're creating an array list of integers, and in the construction of the integers. If we're creating an array list of dog objects, be specific in both. The compiler will implicitly pick things up if you aren't specific, but you know, I like being specific whenever we can. The next thing we're going to do, let's say we want to add 20 elements to our array list, and we're just going to put in random numbers. So for int I equals 0. My students make fun of me because I talk when I type. And we're going to go in and say that we're going to add, well, first let's make a random number. So int rand num equals, we'll say that we're going to do random numbers between -50 and +50. So let's do a little quick review of random numbers in the random number generator. First thing I have to do, math.random. Okay, math.random is going to give us a random integer between 0 and 1, inclusive on the 0 end, but not inclusive on the 1 end. If we want to go from -50 to +50, we have to tell it that there are 101 possible values I could choose from. So -50 to +50, including 0. So 101. We have to take all of that and cast it as an integer. Okay, so that's going to give us, let's see, that's going to give us from 0 up to 100. But then if I want to go from -50 to +50, we'll subtract 50 from that. So we're going to get a random number, and then we're going to go to mylist.1, whoops, mylist1, and we're going to add rand num. Okay, so any questions at this point on what we're doing or why? Okay, so now we'll add another little loop down here that will let us go out and look at whatever we've got in there. So I is less than, and this time instead of specifically saying 20, even though I know there are 20 elements there, I'm going to specify that I want mylist.size. Now, while I'm typing, can anybody explain why I would do mylist.size for the second loop, even though I know there are only going to be 20 elements there?
If you later change to 30 elements, then that next loop will go ahead and work.
Excellent. That's it. Yeah. If I decide down the road that I want 200 elements or 2,000 elements, I don't have to remember to come down and change this now. Whatever the number of elements are that are in my array list, that's what it's going to print, even if I go back and decide to change this down the road. Okay, so let's run and see what we end up with. So we should go out, if I did everything correctly and didn't have any little typos in there, which is definitely possible, we should end up creating 20 random numbers and adding them to our array list, and then we will come down and we'll display all of them. So let's see what we get. Oops, yep, like I said, entirely possible. Cannot find symbol. What did I do? Oh, my list instead of my list 1. Oh, and I'm going to change one more thing just to make it easier to read. I'm going to use print instead of print line so that we don't have to scroll as much. So one of the things that I find, I'm still kind of getting used to doing live coding in my class. I do this with my students every once in a while, and we started using Replit this year. I'm a big JGrasp fan. I love JGrasp. Our school does one-to-one computers. Every student has a Chromebook, and I'm not a big fan of the Chromebooks. Both of my own children came through our system. I shouldn't say I'm not a fan of Chromebooks, because that's like me saying I'm not a fan of hammers. You know, a Chromebook is a tool just like any other tool. It has its purpose, but for what I teach, for me personally, the Chromebooks kind of limit what I can do in my classroom because of the fact that we can't install software. So we can't use JGrasp, we can't use Alice, we can't use Jelliet. You know, we can't do other things that I would like to do in my classroom if we were limited to just Chromebooks. So in my classroom, I have a set of classroom laptops that let us use JGrasp on a normal year. This year, I have to admit, I've kind of moved a little bit more to the Replit and the Chromebook side of things, because we were not allowed to use laptops in the classroom, trying to eliminate touch points and things like that. So I had to let my students use Chromebooks, and so therefore we used Replit. And one of the cool things about Replit that you can't do with JGrasp is you can allow all of the students to have access to the screen at the same time. So it did make it really easy as I was demonstrating things on the screen to say, okay, you take the next line, and then you take the next line over after that. And from where they were sitting, because we were all, you know, working directly on the same project at the same time, it made it really easy for students to pop up what we were working on their screen so they could see better. So I have to admit, I've become a little bit more of a fan of live programming, live coding, and as I teach, and I'm starting to sway a little bit. As much as I hate to say it, I feel like I'm going to the dark side, but I'm starting to sway a little bit to the Chromebook and the Replit side. I'm going to have to think about next year, as things start to move back to normal, whether or not I want to go back to JGrasp or whether I want to stick with Replit. Both kind of have their pros and cons, but in any event, here's our output. You know, we've created 20 random numbers, and like Renee pointed out, if I go out and I change this to 50, I don't have to change anything else in my program. I can rerun it and I'll get 50 random numbers. Or if I decide I want to rerun it and I only want 10 random numbers, whoops, go back there. If I only want 10 random numbers, I can change it so I only get 10 random numbers. So, you know, one of the things I tell my students a lot is be smart in your coding, so that you don't have to go back and make multiple changes. Avoid copy pasting, so that if you change one thing, you don't have to go in 3 or 4 times and change the exact same code. See if you can write it inside a loop so you only change it once. And if we're working with loops, make sure you use mylist.size, or if we're dealing with arrays or strings, use length instead of hard coding numbers. And that way you don't have to remember to go in and change multiple things. It makes it easier for you down the road as you change things. So so here we go. We've gone through and we've added things, and we have I was going to say we have get things, we have gotten things. I don't know what the proper Java term there is, but we've gone through a list and used to get a lot of different things. Okay. So now let's look at what happens if I start removing things. So I'm going to go in, let's see. Now what I should have, yeah, go ahead.
For the loop in from the first loop that you made, how would you get those negative numbers from the math.random thing you used?
How would I get the random numbers? I'm not sure.
Or like, how would you get the negative ones? Because it looks like it's from -50 to 50.
Yeah.
Math.random.
Yeah, so my math.random. So math.random is going to give me -50 to +50. And if you look down here, if I'm understanding what you're asking, are you asking about element values? Are you talking about the values of the elements I'm putting in, or are you thinking index positions?
The values.
The values. Okay, so as I create those values, you can see down here that I'm putting negative values in. So this is the value that's at index position 0, the value at index position 1, the value at index position 2. So using math.random, that's where I'm getting values from -50. So that's my starting value. And I've got a range of 101 values. So that's giving me from -50 all the way up to +50. So my value that I'm plugging in to my array could be anything in that range, but they're going into positive index positions. So, so if I wanted to look for a specific number, let's say, let's do a little loop that's going to let us count the number of negative numbers I've got. So int number of negs equals 0. And then I can say for int I equals 0, you know what, I'm just going to do this. One of the things that we talked about the last time we were all together was some of the different array traversal algorithms, and all of those same algorithms apply to array lists. So any of the things we talked about in traversing arrays, setting values, displaying values, looking for consecutive values, searching for the max, searching for the min, counting number of occurrences of things. I mean, all of those are different things that involve traversals of arrays or array lists or strings that are fair game for especially free response questions. It's not uncommon for the array list question on the AP exam to involve traversing to look for something or to count something or to keep track of the number of times something happened. So this is kind of a good example of using that same array traversal to go through and see how many negative values we have. So if my list one dot get I is less than 0, number of eggs plus plus. Okay. You have there we go. I think I got all that right. Okay, so now we're doing that same traversal, right? We're still going from 0 through the size of our list. And this time, instead of setting values or instead of getting values to display them, I'm going to get the value and compare it to 0 and then just add a count if it happens to be less than 0. So when I run, and I think I've got 10 values in there that we're working on this time. So yeah, there are only 2 negative values. And in this case, those values are -33 and -44. Did that answer your question?
Yeah.
Okay, all right. What's your name, by the way?
Lath.
Lake?
Lath. Tough one.
Yeah, okay, I gotcha. Okay, thanks. I appreciate you asking the question, Lath. Did I say that right?
Yep.
Okay, good. I gotcha. Okay, so let's look at a couple other things. How are we doing time-wise? Oh, we're at 10:45. We've got about 10 minutes left before we have to take a little break before we shift into 2D arrays. So I wanted to show you, let's see, we've done set, we've done get, or no, I'm sorry, we've done get, we've done add. Let's look at modifying this a little bit. Let's set some things. So let's say now, let's say instead of counting the number of negative values, we want to go through, and if the value is negative, we want to replace it with 0. So this is where we're going to use our set. Okay, I'm going to go through, and as I count through all of the elements in my array list, if we find a value that's less than 0, we're going to use the set method to change it. So I'm just going to say if my list one dot get I is less than 0, let's do my list one dot set I equal to. So we're going to replace what's there with, I don't know what would be a good value. We can just replace it with 0, I guess. So anything as we go through that's negative, we're automatically going to replace it with 0. And again, I'm just doing this as an example of, to kind of show how set works. And we're going to get rid of that line. Otherwise, we'll throw a little error. Okay, but I just wanted to make sure to explain how set works. I can take any value and I'm not resizing the array in any way. All I'm doing is I'm saying replace whatever value is there with this new value. So hopefully you'll notice now we've got more zeros in there than we would have had in the past. So yeah, apparently these were negative values before, so we've now set them to 0. Or either that or they were already 0. Okay, so I can use set to do things. The other thing I can do is I can also remove things. So I can say, if my value is negative, let's just remove it. Now, I'm going to ask a specific question about this one in a second, because there's a specific question that I can almost guarantee, either in the free response question or the multiple choice section, you're going to see a specific situation pop up. So I want to run this a couple times, and I want to see if I can force something to happen so that then we can explain why it happens. I'm going to add more numbers for us to work with here. So now what I'm doing is I'm saying, go through, and anytime you find a negative number, remove it. Okay, but there's a problem with this. There's a problem with my algorithm because I'm saying to go through and look at the entire thing, and if I get a value that's less than 0, remove. But notice I've still got some negative values in there. So any ideas what's wrong with my algorithm and why I would still have negative values showing up in my array list.
Because your indices change when you remove them.
Excellent. Absolutely. That's it. What we probably need to do is we need to display this thing twice so that we can see what's really going on before and after. So let me pop this up here. So, all right, so we're going to create our array list of random numbers. We're going to display it, and I might have to run it a couple times to get what I'm looking for. And then we're going to remove what we think is all of the negative numbers, and then we're going to display it again. So let's see if we can force it to do what I'm trying to demonstrate here. Perfect. Okay. Oh, whoops. I need to add another little system.out.println in there. We need a blank line. There we go. That would have been a good example too. Okay, perfect. So notice we've got a bunch of negative numbers up here that are in a group together. And Renee was spot on. If I go through and I find a negative number, my remove method is going to say, okay, let's remove whatever's at position 0 because the value at position 0 is negative. So we've removed it. Remember we said that as I remove things, everything slides down. I'm literally taking that element out of the array list, and then everything slides down and our size gets dynamically changed. So -50 slides down into position 0. But as I come back up in this for loop, we're incrementing I to 1, which means now, even though -50 has just slid down to position 0, we're going to move up and we're going to check the next value. So I'm ignoring the fact that I just moved a negative value into the position that I just looked at. And I'm assuming that once I look at it, I don't have to look at it a second time, even though I replaced the value that's there. So the way we would fix that, actually, there are two different ways, and either way works. I can either traverse this array list in reverse. I can start at the end and work my way forward, because then as I move forward in the array, I'm going to cover anything that hasn't shifted. The other way we would do this, if I want to start at the beginning of the array and work backwards, is every time I remove something, I have to decrement I by 1 so that I back up a step. And then when I come to the for loop, I go back to the value I just looked at again. So now if I run, hopefully we'll see the same thing. Yeah, here's a place where we had multiple negative numbers. Here's a place where we had a lot of negative numbers together. But notice all of the negative values are gone. The only ones that are left are the ones that were originally positive: 19, 35, 9, 47, 35, up here 14, and 38. So array lists are great in the fact that they dynamically change size as you add things and remove things, but sometimes that can cause other kind of trickle down problems that you have to be aware of and be prepared to deal with. Okay, we've got about, I don't know, 5 to 10 minutes left before we take a little break, before we get into 2D arrays. Anybody have any other questions while I'm in here in JGrass as far as programming things that we can kind of play with a little bit? Okay, so I'm going to jump back to my slideshow, and I want to show you just a couple of quick multiple choice questions. You know, I love the fact that we are able to get together and do this, but the one thing I wish we had was more time. I would love to spend an entire day, you know, going through array lists and multiple choice questions and free response questions. And unfortunately, time is just limited. So just some extra exercises, you know, things that you might want to look at down the road, because again, we're kind of pushed for time. Which array list method replaces the element at given position? So as to the students out there, the students that are going to be taking the exam here soon, make sure you are really comfortable with specifically those 5 array list methods. Size, which tells us how many elements are in the array, get, add, remove, and set. Those are the 5 that you really need to know for array lists. You know, write code to be able to do different things. Any of the algorithms as far as array traversals, make sure you can also implement those exact same algorithms for array lists. Make sure that you can add elements to an array list, you know, create an array list that contains 100 random values, and then go through and figure out what the index position is of the minimum value. What's the index position of the maximum value? How many times is the same number side by side if you've got random values? You know, write all these little algorithms to practice. The more practice you get, the better. Let's see. So we've got a couple of practice multiple choice questions. If I have an array list of string items, or I have an array list of string called items, and I do some adding and removing and doing different things, you know, what's the result? If I say system.println items, if I say I want to display it, well, I'm adding A to position 0, I'm adding B to position 1, I'm adding C to position 2, but then I go back and I add D specifically to position 0, which is going to shift everything over. And then I'm removing what's at position 3, and then I add E back at position 0. So as we're keeping track of all this on paper, what we eventually end up with is C. We end up with EDAB because we've removed the C. So take a look. I guess, again, I feel like I'm spinning out of time here. Make sure you go back and look for, look for practice problems, anything you can do like in AP Classroom to assign some array list practice problems, things like that, multiple choice. The other thing I wanted to point out as far as some really good places to look for multiple choice questions. Oh, this is my ACBAR question. Any of the students in the room know why it's called an ACBAR question?
Trap.
It's a trap. Absolutely. This is the one I was just talking about a second ago, where you're going to see something like this, where we have to go through and we remove all of the occurrences of a specific value. So, if I said I was going to go through and remove all of the occurrences of 5, this is another one where I'm going through, and anytime I find a 5, I remove it. So the 3 would slide down. When I remove this 5 slides down, and I would end up skipping it the way it's written. So what I really end up with is an array list that looks like this, if I don't make sure to take into account that I'm dynamically changing size. So that's that same question kind of popping up again. But then there are also some great free response questions out. If you go out to the AP exam page, just do a Google search for AP Computer Science A exam, and it'll take you to College Board's AP exam page for AP Computer Science A. And if you scroll down a little ways, all of the past released free response questions are there, going all the way back to, I want to say 1980 something, back even when I was still in high school. So you'll find questions out there that are in other languages back in the days when, no, it's not that far. It's 19, I don't know, whatever year it goes back to. I don't remember the year, but it goes back at least as far as the C++ days. So you'll see questions out there that were released in C++. But any year that, I think the only year College Board didn't release the free response questions was 2020, last year, because last year was just last year. You can go out and you can pull the free response questions. You can see them worded exactly the way they were on the AP exam itself. And then all of the scoring guidelines, the rubrics, sample answers, all kinds of things are out there. The music downloads free response question is a really good one. I don't recall off the top of my head what year that one was. One of my favorites, whoops, sorry, I jumped out too quick. That one's a good one. There are other ones out there. There's one that was done just in 2019 that involves both arrays and array lists. So those are all, great places to go to look at specific questions that are there, and try different things. And I feel like I ran that really, really fast. But that's kind of the end of our time with array lists. Anybody have any specific questions? Any questions you had about array lists that I didn't cover in the time that we had? Oh, and I'm just looking at the chat. Let's see. Welcome to the dark side. We have cookies. Yeah, I like that. I've heard that one before. In fact, I thought about making that as a poster and putting it on the wall in my room. And then Lathe, you put in the chat that you had a question. Did I answer your question?
Yeah, it was the one about the negative stuff.
Oh, okay. All right. And then Rob, you pointed out that I have a space before the ++. Yeah, I accidentally do that sometimes. As I type in, my finger will hit the space bar, but the compiler.
Well, no, it just surprises me that your compiler is okay with it, because I've used compilers in the past and would not be okay with it.
Huh. Okay. Yeah, JGrasp doesn't seem to mind that. So yeah, that's interesting. Okay. So if there are no other array list questions, next on the list is 2D arrays. But how about, I was asked by Advanced Kentucky to allow for a brief break. How about we take a 5 to 10 minute break? It's I'm looking at my clock on my monitor right now. It's 10:57. How about we split the difference and we plan to be back ready to go at 11:05. That gives us just a little bit over 5 minutes to take a quick restroom break if you need to, refill your cup of coffee, and come back and we'll hit 2D arrays. Sound good?
Sounds great.
Okay. All right, see you back here in a few. And I'll sit tight just in case there are any other questions, if anybody wants to chat about array lists or anything else for that matter. Okay, so now we're moving on to 2D arrays, and I'm going to share my 2D array slide. Let's see, there we go. So again, before we start, anything specific I need to keep in mind, and Lath, I'm talking specifically to you here, I guess. Anything specific, any specific questions you have about 2D arrays that you want to make sure I address while we're going through all this?
I think incrementing through them sometimes is a problem for me. So
incrementing through them. Okay, so so you're talking about just how we traverse through row by row, column by column.
yeah.
Okay, all right, we'll definitely make sure we hit that. So before we get into that, we'll do the same thing we did last time. I'm going to tell you a little bit about 2D arrays, and then we'll break over into JGrasp and we'll play with them a little bit and kind of walk through how we traverse 2D arrays, and we'll kind of manipulate them a little bit and do some cool things. But I guess the first thing to keep in mind about 2D arrays is sometimes it's helpful, at least I feel like it's helpful, and my students tend to agree, that we think about what's really going on behind the scenes with a 2D array. We picture 2D arrays as this. This is how we as human beings, at least how I as a human being, picture what a 2D array is. A 2D array has rows and columns, and I'm specifying the number of rows that I have and the number of columns. So I've got 6 rows numbered 0 through 5, and I've got 8 columns numbered 0 through 7. And so this is kind of what we picture. We have a little reference variable, our bucket, that contains the reference to where this array lives in memory. But what really goes on, what the computer sees, is it sees something like this. When we create a 2D array, what we're really doing is we're creating an array of arrays. So and beyond the AP subset, okay, beyond the AP subset, there's nothing that says that this array that's in position 0, that this little mini array in here has to be the same length as this one. And there's nothing that says that this one has to be the same length as this one. So technically, if I really wanted to, I could create an integer array that has 5 elements and put it here. I could create an integer array that has 200 elements and put it here. I could have an integer array that contains 30 elements and put it here. And if we were to do that, that would be called a ragged array or a jagged array. You hear that sometimes. As far as the AP subset goes, College Board has said, well, we won't do that to you because this is a starting class. So every array, 2D array that we work with is going to be a rectangular array, meaning that every row will have the same number of columns. So if I define a 2D array that's 6 by 8, we're guaranteed that row 0 will have 8 elements, row 1 will have 8 elements, row 2 will have 8 elements, all that good stuff, okay? So this is what the computer sees when we do this. So if I say that I want to know the value of the element at position 2, 3, we kind of picture coming down to row 2 and going across to column 3 and getting the value that's in that spot. But what the computer does is it says, okay, let's go to element 2, and then inside there, let's look at whatever's in position 3, and it finds it that way. So there's a reason that I explain it that way to my students that we're going to get to in a couple seconds, but it helps to clarify what's going on as we think about how some of these traversals work and how we look for certain things. Okay, so take a look at this for a second. Let's say I create an integer array called my grid. So it's going to contain ints with 6 rows and 8 columns. And then I'm going to go through, and this is going to be the little algorithm I'm going to use to traverse through and display whatever value I'm looking at in each element. So this kind of goes back to what you were talking about. We'll start talking about how we traverse a 2D array, and this is in what's called row major order, which we're going to read it like we would read a book in the English language. We'd start at the top row and go across, and then we'll start at the next row and go across, and then we'll start at the next row and go across. Okay, so I'm going to start row equal to 0. As long as my row is less than 6, the number of rows that I have, I'm going to go in and I'm going to pick up each column. So I'll start my column at 0, column is less than 8, so I'll display. And I have to complete this for loop before I increment the outer for loop, which means I'm going to do row 0, column 0, 1, 2, 3, 4, 5, 6, 7, and then I'll stop when I hit 8, and then I increment row to 1, and I go back and I do column 0, 1, 2, 3, 4, 5, 6, 7, and so on and so on. All right, so all of this works perfectly fine. This does exactly what it's supposed to. But the question I put down at the bottom, and again, this is kind of prepping us for what's coming up on free response questions and multiple choice questions on the exam. What should we do differently? There's one thing in here that could cause us a problem potentially. It won't for the example we've got, but it could. Lath, now that you opened your mouth, I'm gonna call you out, buddy. Any ideas?
Could it have to do with if it's 6 by...
Keep
I don't
going. You
know.
got it.
Would it have to do with the fact that its row is like less than 6 and column is less than 8?
That is absolutely it. So the question would pop up, what if I decide, and this kind of goes back to where we were with Arraylists too, the reason that I put dot size in that lower for loop. If I decide I want to go back and say, okay, let's not make this 6 by 8, let's go big. Let's make this 600 by 800. Okay, well, now I'm going to run into a problem when I run this part, because it's going to show me only what's in row 6, the first 6 rows on the first 8 columns. It's not going to show me everything. Or if I decide, you know what, 6 by 8's too big, let's go back and cut it to half the size. Let's make it 3 rows by 4 columns. Well, if I don't go back and change this too, then now I'm going to throw an index out of bounds exception, because as soon as I hit column 4, if I set this so that it goes 3 rows by 4 columns, as soon as I hit the column that it thinks is at column index position 4, it's going to throw an index out of bounds exception, which is going to crash everything. So what we really need to do is we need to think about what actually goes on. Oops, and I accidentally misnamed my arrays here. No, I didn't. Did I? No, I'm good. That's my parameter that I'm passing in. What I really need to do is, if I'm passing in any 2D array, that means this 2D array could have any dimensions. We don't know what the dimensions are. So I don't want to hard code numbers in here. I want to go out and I want to say, okay, tell me what the length, and this kind of goes back to what the computer sees. Remember we said we had an array of arrays. Well, this is going to give me the length of that outer array that contains all of the other arrays. And that's really what my rows would be. So that's why we specified that we want my2d.length. That tells us how many separate little mini arrays we have. It's the number of rows if we think about it. So that way, it doesn't matter if I pass in something that's 6 by 8 or 600 by 800 or 3 by 4 or 30 by 40. This is going to know how many rows there are. And then as we come down inside, remember how I said that every little mini array that's inside each one of those elements of our bigger array, they're all going to have the same. They're all going to have the same length. Well, I could, if I really wanted to, go in here and just say, okay, my 2D array 0, because we said that row 0 is going to have the same length as row 1, which is the same length as row 2. I always tell my students that it would be really impressive if they go off to college and they already know how to deal with ragged arrays. So I tell them, just whatever the length of the array is that's in that position, use that length. And for us, it's always going to be the same. But this way, you've kind of accommodated that. If you get into a later class and you have an array that has arrays within it that are different lengths, this will accommodate that. So this is saying, okay, now go to row 0, go to that first element in my bigger array and tell me what the length of the arrays that's inside there. And that's my number of columns. So this way I can go through, and no matter what the dimensions of this array would be, I know I'm not going to go out of bounds, and I know I'm going to cover the entire thing. I'm going to hit all of the rows and I'm going to hit all of the columns. So that would be the one thing that we could do a little bit different. Okay. Now, like I said, because we're dealing with rectangular arrays, it would be easy just to set this to 0, and then that's perfectly fine too. That's just a little extra I'd throw in. Okay. So as we traverse, and Lath, I'm glad you asked the question you did. This is the basic algorithm to traverse a 2D array. I mean, that's it. And I can almost guarantee, I can't 100% guarantee, but I can almost guarantee that on the 2D array free response question, which as of 2019, the 2D array free response question is always going to be number 4 of the 4 free response questions, that if you memorize this part, you're guaranteed almost, again, I don't want to speak for College Board and I can't 100% guarantee it, but based on past rubrics on past free response questions, you can almost bet that this is going to be worth 2 of the 9 points. If you set up your nested for loops correctly to traverse a 2D array, that's almost guaranteed 2 points in the bank of the 9 points. Okay, so we're starting our row at 0. We're going to go to whatever the array name is .length, and then we're going to go array name row or 0.length to make sure we've got the right number of columns. And then whatever it is we're doing inside that 2D array, that goes in here. That's the accessing part where we're either looking for something specific or we're changing something, I mean, whatever. But this is always going to be the same to go from the top left corner of a 2D array to the bottom right corner. Everybody okay with that?
To modify the elements in an array, do
Uh,
you just do like the array, or sorry, the 2D array's name and then like brackets and
That's it.
equals? Okay.
Yeah, and I'm glad you asked that question because we are going to go back to JGrasp and we're going to play. So I'm going to show you that. I'm going to show you exactly that. That'll be the first thing that we go out and we play with. Good question. Okay, so let's jump back over to JGrasp, and I'm going to get out of my Arraylist little playground program here, and we'll go into 2D arrays. So I'll clear that out of there too. Okay, so same idea. I've got this little program set up where we can go out and play with 2D arrays. And like I said, we have to import array lists, but arrays, and therefore arrays of arrays, that's part of the default package, I guess you could think of, that comes with Java. So we don't have to import anything specific. I'm just going to start by creating an array, a 2D array, my 2D equals new int. Let's make this one 10. What do we want to do? 10 by 20. So 10 rows, 20 columns. That should be okay. Okay, and then like I said, we need our nested for loops. So I'm going to start for int row. And one thing I would suggest, if you're working with 2D arrays, one of the things that I tell my own students, make sure in everything we do as we program that we use meaningful variable names. I give my students roll their eyes when I bring up, I'm going to give you the lecture again, because I give them this standing lecture. The AP exam is not the time to be cute. So I give them my don't be cute lecture because my kids like to be cute in their code. They like to come up with funny variable names and things like that. I had a student a couple years ago that would use variable names like GAC and blarg. And as I'm looking at their program, trying to trace the code and figure out what the program does, it makes it really difficult if you use variable names like GAC and blarg. You have no idea what the purpose of those variables are. So, if I'm doing an array or an array list, I'm probably going to use I as the variable name to represent index position, because that kind of makes sense. If I'm doing a 2D array, then my loop control variables, it kind of makes sense to call them row and column so that I know specifically what row and column I'm looking at. So make sure we're using meaningful variable names in everything we're doing, not just in this case, but specifically, don't use things like I don't know, Abbott and Costello for your row and column, because then you have no idea what Abbott and Costello do. So let's see, we're going to say row is less than my 2D dot length row plus plus. So we'll do the same thing. I can't multitask. We'll do the same thing that we did for our array list. We'll just fill it with some random values. Let's see. Oops. Okay, so we're going to go into each one of these spots, and we're going to say that we want to set my 2D, whatever is at row column, equal to a random int. And we'll just say between 0 and 10. Or let's do 1 and 10 inclusive. Math.random. Okay. Okay, and then again, that same set of for loops for traversal. Now, 2D arrays are a little different if you want to display 2D arrays, because I want to make sure that I'm showing it as an actual 2D array, which means inside the column, I want to display all of the columns going across. So my 2D. And we'll put a little space in between. And then every time I finish a column, I need to tell it to go down to the next row. So system.out.println, we'll just do that so we get a blank row. Okay. All right, everybody okay with that? Questions before I run it? Okay, let's see what we end up with. Okay, so we got that. I tell you what, just so everything lines up right, I'm going to eliminate 2-digit numbers. We'll make it 1 to 9. That'll make it a little easier to see. There we go. That's a little better. So, so the reason I wanted to eliminate the two-dimensional or the two-digit numbers is because it adjusts the spacing and things. And we could have gone in and used, /T to tab, and that would have fixed things up a little bit. But this makes it a little nicer to work with. So, so now we can kind of play with this a little bit. Now we can go through and we can start doing some of those same array traversals that we would do with arrays or array lists, and we can do them with 2D arrays. We can go through and we can look for, the number of times that I have two numbers side by side. And because we're dealing in 2 dimensions now, that means side by side could mean, I have two numbers that are the same number, one above or one below or one to the right. We can go through and we can kind of check for things that way. So I guess first off, Laith, to answer your question, if I want to look at a specific index position, I can put in something like my 2D, and I can give a specific row and column. If I want to look at whatever is at position 5, 7, I can do that. So I can go specifically, whoops, hit the wrong button. I can go specifically to, oh, forgot my parenthesis. I can go specifically to row 5, column 7, and see exactly what's in that spot if I want. And it looks like row 5, column 7 is an 8. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. I think I cut off by 1. 1, 2, 0, 1, 2, 3, 4, 5, 6. Yeah, there we go. 7. That one. So we found the value in that specific spot. But we also have to start thinking about, because we're in 2 dimensions, the algorithms could get a little more complex. So let's say I wanted to go through and count the number of times that a value has the same value either to the left, right, above, or below. In other words, let me see if I can find a good case here. Like right here. This 7 has a 7 to the right, and it also has a 7 below it. So I could count the number of times that I have any value that has a value touching it in one of the 4 directions. So think a little bit about some of the things that would go into writing an algorithm like that. I still have to traverse my 2D array. Let's do this. I still have to traverse the 2D array. Oh, stop it. There we go. I still have to traverse the 2D array, but there are some extra little things I have to think about as far as the traversal goes, because again, I have to make sure I'm not going out of bounds anywhere. And I also have to make sure I'm being careful. Well, I mean, that's really, I guess, the big thing. The big thing I have to really be careful of as I go through and I do this count is I have to make sure that I'm not going out of bounds anywhere. So where would I need to start if I'm going to be checking all directions around without going out of bounds?
Would you put like row +1 or column +1?
I would. Yeah, I'm going to end up doing a comparison to whatever's in row column to whatever's around it. But again, I have to do that very carefully to make sure that I'm not going out of bounds anywhere. So, here, let's do this. For this one, instead of counting, how about we display the row and column of any element that has a value touching anywhere around it. So I guess the base case would be if my 2D row col -1. So we'll check all the different directions. So this will check above, or, so this is where things are going to stack up quite a bit. My 2B col. So now we're going to check to the right. So this will be my 2D. We're still in the same row, but we're looking at column +1. Oops. And I'm going to come down just to kind of keep everything on the same screen. Or my 2D. I probably could have copy pasted this faster. Row +1 col. Oops. Now we'll look on the left. So my 2D, oops, and I have an extra lowercase d up there. Oh, I did that a couple times. That's my downside. The more I type, the more typos I have. So let's see, we're going to do row. Where am I at? The same row, but we're doing column -1. Okay, so that will automatically look all the way around us. So we're going to say, so if I find that, we want to display the row and column. So we'll do let's row. I should have had this preset. Sorry about that. Column. Plus. Okay, so if I go through and I find anything, you know, anywhere around that has anything around it, and if I'm going to do this and I don't want to throw bounds errors with just this part, then I need to make sure that I'm not checking anywhere in this outside row. I need to start here, and I want to get everything over just that far, because I need to make sure that I have room to check to my left and check to my right and check above and check below. So I'm going to start at this position 1 1, and I'm going to work down to this position. That'll be the last one I can check, because if I try and do anything in this column, then as soon as it tries to look at column -1, it's going to throw an index out of bounds exception. If I try and do anything in this top row, when it looks above it, it's going to throw an index out of bounds exception. So this would be where if I'm only looking at the innermost things and I don't have to check the borders, I can start here and I can stop here. So I'm going to do the first row. I'm going to start with row 1 and I'm going to stop one row short. And the same thing with my columns. So I'm still doing the array traversal. I mean, I guess my definition of a traversal is I'm going from a starting point to an ending point, and I'm accessing all of the elements between those points. While I'm still doing an array traversal, it's just now I'm kind of adjusting the boundaries so that I make sure that I don't go out of bounds anywhere. So when I run this, oops, what did I do? Oh, I forgot to close my if. When I run this, I'm going to get a list followed by all of my values. Did I do another one? Oh, make sure I don't have any more of those. My students love it when we do, oh, and I still ended up with an index out of bounds exception. So let's figure out where my index out of bounds exception is. My students love it when I do this kind of stuff. Because they love it when they catch me doing little programming, you know, when I have my little programming errors on the way as I go. So let's see. So where are we getting our index out of bounds exception? Oh, I didn't do the length -1 here. Oh, I think, okay, so what I did.
Shouldn't you also start your row and your column at 1?
I should. So when I did that, I fixed my index positions in the display and not, yeah. Like I said, that would be something my students would get a kick out of. There we go. So I made all the right changes, just to the wrong for loops. There we go. Let's try this again. Okay, so here's our list of all of our elements that contain values that are around them. So if I go to row 1 position, or row 1 column 1, I'm going to have at least somewhere around it a value that's equal to that value. If I go to row 1, so they should be a lot of them kind of paired up. If I go to row 1 column 2, well, we just saw that I have one beside it going that direction. So now I'm going to get a list of all of the elements in here, and I can go through and I can make changes to those, or I can do whatever I want. I guess the big question would be, if I need to fix this so that I include the borders, what would I have to do with that part? And that's kind of the big question. How do I protect to make sure that I'm looking at all of the borders as well? Well, now the code would get a little more involved, and we're not going to quite go into that level of detail, but I would have to put in some kind of a check to say, okay, if my current row equals 0, then only check these 3 directions. If my column equals 0, I'm only going to check these 3 directions. If my column is equal to length minus 1, then I'm only going to check these 3 areas. So we have to put in more if statements that way and check other things, but we always have to make sure we're checking to make sure we're not going out of bounds. One of my favorite 2D array questions is called gray image, and I've got a copy of it in the PowerPoint slide. We'll look at it here in a second. But one of the things that gray image involves is that you have to go through and run a certain algorithm that will change all of the values in the 2D array by subtracting the value that's 2 to the right and 2 down. But you have to be careful that when you set up the algorithm to do that, that you're only going a certain distance and you're not hitting anything that would be out of bounds as you try and subtract that value. I can't subtract a value that would be out of bounds. So those are the types of things that are going to pop into these questions that for the free response questions that we need to make sure we're looking for so we don't end up with bounds errors and different things like that. Questions at this point? Pardon me.
For that 2 one that you were talking about, would you have to do like if I is less than or yeah, if I is less than or equal to 2
Yeah,
or something like that?
Yeah, let's play with that a little bit with this one. So let's say, I'm going to go back and I'm going to do this. And there are a couple different ways you could do this. Let's say I want to do exactly that. I want to go through and if I find a value that's equal to 4, we'll do this. We'll just kind of make this up on the fly. If I find a value as I'm traversing this thing that's equal to 4, then let's say I want to go 2 to the right and 2 down, and I want to subtract whatever value is in that position. Okay, so we're going to start by saying if my 2D array row column equals 4, we'll get rid of all the rest of this stuff. Make it a little easier to see what we're doing. If my 2D array row column equals 4, then I want to go through and I want to say, okay, we're going to replace whatever's in that row column with whatever's 2 to the right and 2 down. My 2D row plus 2 column, whoops, plus 2. Okay, so now the problem with this is if I do this, when I get to the point that I'm looking, get back here. When I get to the point that I'm looking over here, like for example, this one, okay, I'm going to find a 4 and I'm going to try and go 2 to the right and 2 down, but there's nothing in that spot, which means I'm going to throw an index out of bounds exception. So I somehow have to protect this algorithm from going out of bounds anywhere. There were really 2 different ways for that question that students did it. One thing would be to just say, okay, we're not going to go that far. We're just going to stop too short, which means I'm only going to go, as I work through this algorithm, I'm only going to go this far, and then I'm going to stop, so that if I find something, whoops, one more. So that if I find something here like this 4, I can still go over 2 and down 2 and not be out of bounds, but I don't want to go beyond that point. And I also want to stop at this row, which means if I find something, here, here's a 4, then, whoops, one more. No, that's right. I can go over 2 and I can go down 2 and I'll find that spot. So we can stop 2 rows early, or we can stop 2 columns early. So that was one approach that that a lot of students chose to do. They just protected it in the for loop to make sure we're only looking at the things we want to look at. And if we do that, that'll be perfectly fine. Okay, so and you'll see places in here where it looks like, we might have had, oh, I didn't tell it to display again after that. So it's only displaying before. So we need to add another display. The other way, we'll add that in a second. The other way I saw students do this is if my 2D array row column equals 4, and so they left all this the same. Oops, dot length. They did it this way. They said if my 2D array row column equals 4, and let's see, row is less than or equal to, let's see, what do we want? My 2D dot length minus 2, and column is less than or equal to my 2D dot length minus 2. So now what they're doing is they're going through and looking at everything, which means that as I'm looking at my 2D array, they're still getting over here, but then before they do anything, they're checking to make sure that they're checking to make sure that if I add 2 to rows and columns, that it's going to be in bounds. So if by some chance I go in and I'm looking at my last row and I say, okay, well, if I add 2 to that, am I going to be out of bounds? Or if I add 2 to that, am I going to be out of bounds? Then just ignore it. So they just made it part of the if statement. So that would work for us too. I'm going to go ahead and put this for loop down below so we can see it before and after, so that we can see some of the things that have changed. So let's run it again and see what we get. Oh, I did it again. What happened? There's something going on in here. Row, whoops, less than, not less than or equal. There we go. Okay, so now if I look at the original, here's a value that's equal to 4. Well, if I go down and I look at that same value, 698125711, okay, well, I've got -1 in that spot now, because if I take my 4 and I subtract the value that's over 2 and down 2, I'm taking 4 minus 5, which gives me -1. Here's another 4 where I'm going to end up with a -1. Well, that's funny that the 4s seem to be subtracting 5s, but over here, notice I've still got my 2 4s in those columns, because I can't go over 2 and down 2. So that way I'm still doing what the algorithm says I need to do, but I'm kind of protecting, so I make sure I don't throw an index out of bounds exception. And I love telling my students, yeah, I did that on purpose. So be careful. Again, it's easy to throw in a less than or equal to. I did not do it on purpose, but it always makes for a nice demo when I make a little goof as I'm doing live coding like this. Make sure you're being careful about less than versus less than or equal, because anytime you're traversing arrays, it's that less than or equal to versus less than is going to kind of make the difference between creating a bounds error, and a bounds error will cost you a point on the free response question. So. Okay, how are we doing time-wise? It's 11:37. Okay, we're doing great. Other questions, other things we need to look at? Lathe, did you have any others?
Just like a question about the test in general. Are they ever going to make you display all the stuff?
No. In fact, I'm glad you said that. That kind of goes along with my Don't Be Cute lecture for my students. I don't think, let's see, I started reading and scoring AP exams, I think in 2008, and in all the time I've been doing it, I've never seen a question where you were asked to display anything. So typically there's always a 1-point penalty for adding extraneous code. This is how it's worded on the scoring guidelines. If you add extraneous code that causes a side effect, it's an automatic 1-point penalty. And it's not uncommon to see students who, again, they're being nice, but they're kind of trying to be cute, and they'll put little things in their code like system.out.println, thanks for reading my exam, or system.out.println, please give me a 5. System.out.println, have a nice day, which is all very nice, but it's extraneous code that causes a side effect. You're displaying output to the screen that you were asked, that you weren't specifically asked to display. So by doing that, it's an automatic 1-point penalty. So a score that would have been a perfect 9 out of 9 now becomes an 8 out of 9 because you added that system.out.println. So I can't say with 100% certainty. Again, I don't speak for College Board. I don't work for College Board, and I have no idea what the questions are going to look like this year. I have never seen a question, or in my time as a reader, I haven't seen a question where you were asked to display things. I guess that's not to say that there wouldn't be a question where they specifically ask you to display things, but I could tell you that it's really not likely. So unless the question very, very specifically says to display something, avoid putting system.out.println anywhere in your code, because it'll cause a side effect. You're displaying things and it'll cost you a point. Okay. Now, that being said, in the multiple choice part, then yes, that's where they're going to say, what would be displayed by running this code segment, or which of the following would be the output displayed, things like that. So that's where you're asked questions about what could be displayed or what might be displayed, not what might be displayed, but which of the following would be the output from a specific code segment. But free response question, not likely based on past questions. Any other questions? Okay. Anything else that you wanted to see from the programming standpoint before we jump back to the slide deck? Any other questions that we could code real quick? Okay.
I think so.
Okay, I'm going to go ahead and jump back. I have a couple of practice questions that we can look at. So some 2D array exercises. let's see, I'm going to kind of jump ahead a little bit. So I guess and Lathe, again, I'm talking specifically to you as the representative student in the group. If you're looking for 2D array practice, just challenge yourself to do little things like this. Let's assume that we have this 2D array called str2d that's been declared and initialized with a 2D array of strings. Write the code to replace each of the str2d elements with even or odd. That's actually something else we probably need to go back and look at from a coding standpoint. I know I said we were done coding, but I want to show you one more thing that this kind of brings up, because 2D arrays and 1D arrays for that matter, of objects are a little different than primitives. In the program that we just wrote, we created this two-dimensional array of ints, and by default, if I create a 2D array of primitive data types, every element is preset by default with a certain value. So when I create this 2D array of ints, I'm going to comment a lot of this stuff out for a second, just so we can kind of look at something specific without all the rest of this running in the background and garbling things up. I don't have to go out and give everything an initial value. I can go out right off the bat and say system.out.println. Let's see, what did we do before? We did my 2D 5, 7. And I don't have to worry about initializing those values. Anytime I create a 2D array or a 1D array for that matter of primitives, it's given an initial value. So this is just going to come up as 0. So anytime I create a 2D array of numbers, whether it be ints, doubles, long, float, whatever, the default value is going to be 0 until I go in and change it. If I change this though, and I say I want to do a 2D array of objects, and strings are included because strings are objects, now that's a little different. Okay, now I'm going to get this null pointer exception. Incompatible types, whoops, strings cannot be converted to, oh, that's not the error I thought I was going to get. I forgot one. I'm going to get what's called a null pointer exception because, in this case, the compiler just gave me null. If I try and create a 2D array of DVDs or dogs or whatever, what I'm doing is I'm creating a 2D array of reference variables. It's kind of the equivalent. So I'm going to, even though I don't have a dog class, I'm going to do this just so I can kind of show you what it's going to look like. Doing this would kind of be the equivalent of doing this, dog, my dog. Okay, so I'm creating a reference variable to a dog. If I do that as a 2D array, I'm creating, in this case, 200 reference variables to dogs. Every element of my 2D array is going to contain an empty bucket that could eventually point to a dog object. Just like I have my single variable called my dog, that's an empty reference variable that has a null in it because I haven't actually constructed a dog object to put in it yet. So just like I would eventually somewhere have to say my dog equals new dog, okay, I also have to do that with my 2D array of dogs. I have to take every single element in my 2D array and I have to construct a dog object to put into it. So somewhere down here, I would have to go into my 2D array and I would have to say my 2D array row column equals a new dog object. Otherwise, if I try and reference any one of those dogs that's in my 2D array, I'm going to get a null pointer exception because every single one of those is an empty bucket that contains null. If I went right after this and said my 2D 5, 7 dot bark, it's going to try and go to the reference variable that's at row 5, column 7, and it's going to look for a specific dog object so that it can tell it to bark, and it's going to say, hey, there's nothing here. This is nothing but null, so you now have a null pointer exception. I can't tell a null to bark. So we have to go down and we would have to construct this entire 2D array with new dogs before I could actually do that. And once I do that, then that's great. I now have 200 reference variables that point to 200 individually constructed dogs, and I can pick any one of them and tell them to bark. But I wanted to make sure to focus on that a little bit and stress that because 2D arrays of objects are a little different than using primitives. They don't get a default value other than null. I guess null would be the default value they get. Okay.
Can you set something to null?
Can you set something to null? Absolutely. Let's see. So I can do this, and we're kind of getting back to the classes and objects things a little bit, but we can break off here on a little tangent. If I say dog, my dog equals new dog, later on in the program somewhere, I can say, I can do that again. If I decide I don't like my dog, I could say something like You know, I could do dog, your dog equals new dog. And then somewhere later in the program, I could say my dog equals your dog. Okay, I could basically steal your dog. And so now we have reference variables that both point at the same dog object. And if I totally want to take away your rights to your dog, then I could just say your dog equals null. So this is all about reference variables. You know, I create an empty bucket that contains a reference to a dog, and I slap a label on the front of the bucket that says my dog, and then I put the address of where this constructed dog is into that bucket. And I do the same thing with your dog. You know, I create a reference variable that can contain a reference to a dog, and I put a label on the front of that bucket called your dog. Well, all I'm doing is at this point is I'm taking the memory address out of the bucket that has your dog, and I'm adding it to the bucket that has my dog. Okay, so now they're both pointing at the same object. And then I can come down, whoops, not you dog, your dog. I can come down to the bucket that contains the address for your dog, and I can replace the address that's in there with null. So now that bucket has a null. It doesn't point to anything. The object that was originally considered your dog is now referenced by the bucket that says my dog. So if I go to your dog and I say your dog.bark, I'm going to get that null pointer exception. So yeah, so that's how we can kind of cut that tie. We can tether, cut the tether that connects us to an object somewhere. And we can do that in 2D arrays too. I can go into my 2D array and I could just as easily say my 2D bracket 5 bracket 7 equals null, which means now that specific element does not have a reference to a dog anymore, but all the rest of them would. Okay. All right, any other questions on that? We kind of went off on a little tangent, but that's okay. I think that was important. Typically on the free response question, I've seen free response questions with 2D arrays that have specifically dealt with primitives. There was one specifically that was it wasn't called light bright because I think that's a copyrighted term, but it was basically the light display question where you're building a light bright and every element is a Boolean that would be either true or false. True if the light's turned on in this spot and false otherwise. You'll see 2D arrays that deal with numbers, but it's not totally unheard of that you could end up dealing with a 2D array of some specific type of object where you're given the definition of an object and then you construct a 2D array of those objects and you have to go in and do certain things. So I'm going to jump back to the PowerPoint again, and that brings us back to this question. So we assume we have a string 2D array that's been declared and initialized with a 2D array of strings. So I've got string objects filling this 2D array, and we're supposed to write the code to replace each of the elements with even or odd, the word even or odd. Even should be assigned to elements where the sum of the row and column indexes is even, and odd should be assigned otherwise. So essentially, we're going to traverse the 2D array, and if the sum of the specific row and column of a specific element is even, then we're going to fill the element with the word even. Otherwise, we're going to fill it with the word odd. Pardon me. So I don't want to take a lot of time. So take just maybe a minute and think about what this might look like. And then I'll pop the code up and I'll show you. We're at 11:48. We've got a little over 10 minutes left. And I know we're supposed to end at noon, but as long as it's okay with Advanced Kentucky, I'm happy to stick around after that and answer questions as long as anybody has questions. I don't know if we have to, cut the tie at exactly noon or not, Monique.
No, if you want to go on longer, we can go on longer.
Okay, all right. I get into this stuff. I could do this all day.
Well, not that long.
Not that long. No, we won't go all day. We won't go all day. Okay, so here's what the code would look like for this. Now notice again, we've got that standard for loop that counts rows. We've got the standard for loop that counts columns, and the only thing that's different is what we're doing inside that. So this is probably some good review of what modulus does. If I'm checking to see if something's even, by definition, an even number is any number that's evenly divisible by 2. And we always check divisibility using modulus. Modulus is what gives us the remainder of a division problem. So if I get the sum of the row and column, and then I check to see what the remainder would be when I divide by 2, and that remainder equals 0, that means that row plus column has to be evenly divisible by 2 with no remainder, which makes it even. So we can go in and we can set str2d row column equal to even. And my students always laugh at me when I do this. You know, this is not me being cool trying to do air quotes. This is a string. So in my class, anytime I do this, we're talking strings. If we were in a Python class, for example, you know, this would be single quotes, double quotes. Actually, in my Java class, when we're talking about individual characters, I'll do this. That's a character. This is a string. If by some chance this is not true, in other words, I take row plus column, I divide by 2, and I get any other remainder, and you know, the rules of math say that if I divide by 2, my remainder is either going to be 0 or 1. If it's 0, it's even. If it's 1, it's odd. So we go through and we populate the entire 2D array with evens and odds. Okay. So now let's take a look at a couple like practice multiple choice questions. So let's say I have this 2D array called mat. And we have this void method called mystery. And so a void method means it's not going to return anything. We're just telling it to take mystery and do something. And we've got our array traversal. It's a little bit different in regard to the fact that we're starting at row equal 1 and not 0, but otherwise everything's pretty much standard across the board. You know, we're going up to, but not including mat.length. And then down here, we're starting column at 0 and going up to, you know, whatever the length of our row is. So we're getting the number of columns. And we say if row is not equal to column, we want to change the value of the row and column to whatever row minus 1 column would be. So this is not too far off from the little example that we did in class, except now we're going through and changing things a little bit differently. So I guess the first question I would have would be, why do you think we're starting row equal to 1 and not 0?
You got row minus 1 in the if statement.
Good, absolutely. Yeah, we've got row minus 1 in the if statement. And I have to be careful. If I start row equal to 0, then when I come down here, row minus 1 is going to tell me to look at row -1, which would be out here in no man's land somewhere, and there is no -1. So again, we're kind of protecting our boundaries to make sure we don't go out of bounds. Perfect. So now they're telling us to assume that mat contains the following values when we start. And it says, note, they're reminding us with this little prompt that our rows and columns start at 0. So row 0, column 4 is going to be equal to 2. That's this one. So what it's asking is, which of the following, which of these A, B, C, D, or E, what values does mat contain after a call to mystery? So if you think about this, I mean, we could go through and we could trace everything, which is not a bad idea. We're going to start at row 1. And as long as the row and column do not match, we're going to replace with whatever comes above it. So in this case, we're going to replace the 1 with a 4. We hit this point. This is where 1 row and column match. This is row 1, column 1. So we're not going to touch that one at all. And then we're going to move across, and they're not equal. So we're going to replace the 7 with a 4. We're going to replace the 5 with a 3. We're going to replace the 3 with a 2. And you can kind of see that pattern. I'm going to move my little window out of the way here. Let's see, I'll move over there. So you can kind of see that pattern. So we can look at this and say, okay, as I get to this one, I'm going to end up with 4, 8, 4, 3, 2. So you can almost look across and say, okay, well, I can eliminate certain answers because I know this isn't right. I know this one's not right. We can kind of start playing a little bit with what we're going to end up with as we're looking at some of these things. 4, 8. Okay, so as we look at the next row, we're going to replace 7 with what comes above it. Well, we just replaced this one with a 4. We just replaced, actually, we didn't replace this one. So this one's going to become an 8. And we can keep kind of tracing this through. And by the time we get done, again, for the sake of time, I'm going to pop the answer up. We end up with this answer. Now, there's something in there. I'm wondering if there's a typo in this question. -1.
Well, for me, there were only 2 possibilities. Since I know that the major column isn't changing when column equals row. And the only ones that have the column equals row.
Oh, yeah. I'm assuming there's,
E.
I'm sorry. I'm assuming there's an else in there. Sorry about that. I got a little distracted by what I was looking at. So the only ones we're changing are the ones where this where it doesn't we're only changing if row is not equal to column. So that was my bad. So
Yeah.
yeah, so we are looking at the correct answer. Sorry about that. I was thinking there was an else tucked in there, but there isn't.
I mean, that alone eliminates everything except A and E, and we know
Yeah.
that.
So yeah. So
So
good question. Okay. Any questions on this one? See, that's what happens when I get into a hurry. I tell my students, make sure you're tracing things on paper, and then I fall into my own trap, and I don't do that. So if we're tracing on paper, you know, I tell my students all the time, be the compiler. Make sure you're writing on paper as you're tracing through code, and don't assume things. And every once in a while, I fall into that trap on my own, if it's something I haven't looked at in a little while. Okay, let's look at another one. Let's take a look at this one. So now we've got this 2D array called mat, which is a 3x4. We have our, again, standard traversal, you know, our standard for loops. And now we get into something where we do have some different conditions. We've got, if row is less than column, we're going to do something specific. If row equals column, we're going to do something specific. And if not, if we get into the situation where, again, row is not less than column and row is not equal to column, which only really leaves one choice, row has to be greater than column, then we're going to change things to a 3. So again, this would be a case where we go through and we trace things out on paper. We make sure we're looking at what happens when row equals 0 and column equals 0. Well, that's going to be the case where we end up with 2. So we'll have a 2 in our 0, 0 position, and then we go up and we increment column again. So now our row 0 is going to be less than column, which is 1. So we'll go across and we'll do 1. And as we trace through, we're actually going to build the array and see what it is we end up with. And I'll give you a second to look before I show you what the actual answer is. Okay, so answer to this one ends up being D. And you'll notice we've got our little line going down through where row and column matches. Anything down below is where the row is greater than column, and anything that sits up in this side of this kind of imaginary line you can picture going down through is where the row is less than the column. So you can kind of see that way where things are being built from. I did want to we're down to just our last couple minutes, and I wanted to show you an example of a couple of multiple choice questions. So I'm going to kind of skip across those quick. This is one of my favorite 2D array questions. This is the gray image question, and I believe it's from the 2012 exam. You have a 2D array that represents a number of pixels. They're either it's an integer value that's somewhere between 0 and 255, and we have to go through and the very first part A, says that we're going to go through and we're going to count white pixels. And if you look at the packet that I put out in the folder for everybody, there's a copy of this question. That's why I didn't post the whole question. But the idea behind this is we have to go through and we have to access all of the elements of the 2D array. We have to compare every single value with either a constant variable that's been declared called white with a value of 255, or directly with the value 255. And every time we find a pixel that's considered white, we initialize and increment a counter, and then we return a correct count of the number of white pixels in pixel values. So for something like this one pretty much meets the example of the ones we've talked about. We're going to traverse the entire 2D array, and as we work our way through, we're just going to count the number of occurrences of 255. So here's an example. And Laith, you asked when we were doing Arraylists, and I don't think we actually ended up doing an example now that I'm thinking back, because I forgot. You had asked if we could do a for each loop using an array list, and that question is true, but that question is also true for arrays. I can create a for each loop for an array. I can go through, and if I use a for each loop with a 2D array, the next kind of breakdown part of that is I can pull, just like I can pull an int from a 1D array, or I can pull an int from an array list, I can pull a row from a 2D array. So in this case, we're getting each row. I can pull a row from a 2D array, and then within that row, I can pull each individual integer. So this outer for each loop gives me the rows, and then this gives me each value or each column from within the row. I probably need to address the point that this has the word this in it. We use this if we're inside a class to reference a method or an instance variable within the same class. It is not required. During the time period that this question was on the exam, what the chief reader for the AP exam was a college professor that was adamant about the use of the word this, even though it's not required. So every solution that you'll see on the AP website for that time period includes the word this. You know, some people argue that it absolutely should be there. Some people fall into the camp that it is not necessary and it just confuses things. Either way, the compiler will take it. It basically just says within this specific occurrence of the object, grab pixel values, and within this specific occurrence of the object, grab the value white. We're just defining a specific object, just like we would with anything else. You know, if I say, you know, my dog.bark, if I have a method inside the dog class that calls the bark method, then I could say, okay, for this specific dog, you know, this object within itself, tell it to bark. But that anywhere that you see the word this dot, you could just cross that word out and the code would still run and do what it's supposed to do. For the second part of this thing, that's where we're supposed to go through and we're supposed to subtract whatever's 2 over and 2 down from the value that's there. If it goes negative, if there's a value that would happen to go, well, no, I should say if it happens to go negative, then we replace it with 0, which would make it a black pixel instead of a white pixel. And then that would be where we have to go through and we set up our code kind of like we did in the example to make sure that we're protecting our boundaries and not going out of bounds. And here is an example of that one. So like I said, there were really 2 different solutions to this one. There were some students that protected by making sure we didn't actually go into that area. So they set the for loop up so that we kind of protected from there. And there were other students that built into the if statement. You know, in this case, they said if row plus 2 is less than pixel values dot length and column plus 2 is less than pixel values row dot length, then we can go in and we can do what we need to do because we know we're not going out of bounds at that point. So. Okay, that brings us to our time. In fact, we are 1 minute over. It's 12:01. So like I said, I'm happy to stick around for just a little while. I would love to be able to do this all day, but I know we can't do that. Everybody has things that we need to do. But are there any questions, anything I can answer that I didn't answer already? You know, Lathe, I feel bad that I forgot to show you an array list with a for each loop. So if you would like, I can go back and I can show you an example of that quick. But any other questions that we've got that I can cover before we separate and go our separate ways?
You said that you won't get points counted off if you don't put this dot, right?
Yeah, you won't get points counted off if you don't put this dot.
Okay.
Yeah.
And are a lot of questions like this where you won't, or where you have to do like minus equal, or like a certain pixel equals like the pixel minus?
I don't, again, every year the 2D array question is a little bit different. So, you know, the main thing, I guess the best way for me to answer that question is to say that as you're looking at the 2D array question, make sure you understand the concept of the boundaries of the position. There could be something where you have to make sure that you're not going to throw any bounds errors. So there could be something like this where you're expected to, you know, take multiple values and add them together or do different things with them. I can tell you that pretty much every rubric is going to say somewhere, at least based on what I've seen in the past. The rubric usually says something to the effect of, does it access an entire row, or does it access an entire column, or does it access all of the elements? But each time you see that on the rubric, it'll have the little condition on the side in parentheses that says with no bounds errors. So we always have to be aware of our boundaries and the size of our array or our array list, or our 2D array, to make sure that we don't go out of bounds somewhere, regardless of what we're doing. So I can't say that, you know, I can't say that it's guaranteed to be something where I have to do row plus a certain amount or row minus a certain amount. I mean, again, that's going to kind of depend on what the question's asking you to do. But regardless of what the question's asking us to do, it's almost guaranteed that you're going to have to traverse a 2D array or a 1D array or an array list, depending on which question we're looking at. And it's going to require that you make sure that you're not going out of bounds.
Okay.
Okay. Other questions? Lathe, were you interested in sticking around and doing a for each loop with an array list?
Sure.
Okay. All right. Let me switch over and I'll show you that quick. All right, so I'll go back to my array list stuff and I'll move this back out of the way.
So Rob, if I can take a minute, because I'm going to go ahead and cut off the recording while you help him. But to finish off the recording, I'm going to share my screen for a second.
Oh, okay. All right. Yeah, and I wanted to make sure to thank College Board for putting exams together, and to thank Advanced Kentucky for the opportunity to come and be with everybody and answer questions and help everyone in whatever way that I can. So thank you, Monique.
Oh, no problem. Thank you so much, Rob. For future viewers out there, I guess if you're watching this recording, you don't need this, but For those of you still on the call, a reminder of where you will be able to find a recording of today's sessions. It'll be at bit.ly/ADVKY with the KY capitalized. Capitalization is important in bit.ly link, so keep that in mind. And speaking of thank yous, I'm Monique Rice, Senior Content Director for Computer Science and Math. Acknowledgements to Erin Timmons, who puts together all of our content review sessions for math and CS for the College Readiness Program. Big shout out to Rob for presenting today. If you need handouts, the recordings, here, those are where we'll find those bit.ly links for the handouts and the recordings. And our next, and I assume our last, content review session for CSA will deal with inheritance, recursion, and exam prep with Richard Kick on May 1st. Thank you so much. Laith, Renee, Rob, if you all want to hang around, you can do so. I'm just going to stop the recording now.
Okay.
And the share, because don't need to share anymore.
Okay, so let me